Hello CSI 135 Section 400 students. This is the video lab tutorial for lab number 8 from last week, where you had to create 4 small shell scripts, and we're going to walk through each of those scripts right now, and I'm going to show you how to create all 4 shell scripts. So the first shell script asks you to create a shell script that is going to prompt the user for their Vader login ID and then prints a message showing their default login shell. So we'll call this login shell.bash. So the first line, we want to declare with the magic number the absolute path name to the shell that we want to execute this script. Again, you would want to make sure that you put some good comments in here, and I always like to draw a comment box of about 75 characters. And then we'll come down. So you usually have title, and this is login shell, login shell.bash. Date, we'll put today's date. And purpose, to list the login shell of the user. And then you might even want to put in author. So if someone's looking for the author of the script, they would know. Okay, there we go. All right. So again, script number 1 says create a script that prompts the user for their login ID. And so we are going to say, please enter your login ID. And then we want to read in, and we're going to create a variable here. We're going to read in the input from the user, and we'll make our variable just login ID. Then the script needs to print out a message showing their default login shell. And this would simply be done by executing the command. And again, you can go ahead and cat the etc password file, grep on the login ID. Oops, sorry about that. $sign login ID. And then awk. And we'll print field number 7, the last field, which contains the user's login ID. And then I always close my scripts with into file. So that way you know where it ends, where the file ends. Okay, so let's see what happens here. So I'm going to save my file. Remember, you need to make the file executable, chmod u+x, and then the name of the file, login shell.bash. So is this going to work? Let's take a look and see if this works. Please enter your login ID, CSI 135B25. And sure enough, the login shell is /bin/bash. And I can confirm this. If I cat etc password and grep on CSI 135B25. And sure enough, the 7th field is /bin/bash. Now remember, this construct here at the end of the pipeline is saying we're going to use the awk utility. The -F is the capital F is the field separator, so I'm declaring the field separator to be the colon. As soon as I do that, I have 1, 2, 3, 4, 5, 6, and then the 7th field is the default login shell. All right, so here is the script, or one way that you could have scripted out the answer to number 1. Okay. The second script says create a script that prompts the user for their login ID and then prints out all the times the user is logged onto the class system. So again, this is very similar to the login shell. So I'm going to copy login shell.bash to, we'll call it user logins.bash. So if I vi user logins.bash, I'd want to come down here and we're going to change the title, user logins.bash. And obviously the purpose is going to change to list the times the user has logged onto the class system. Okay, so again, we're prompting for the login ID, so we'll keep it that way. And then this is actually a much easier construct. It's simply last $, login ID. All right, so let's see what this file does here. So we're going to clear our screen. Now let's take a look at the file user logins.bash, and it already is executable because we copied it already. So if I do /user logins.bash, it asks me for my login ID. And there you go. So since the last time the log was rotated, which was April 2nd, about 2 weeks ago, a little over 2 weeks ago, you can see that, oh, whoops, I apologize. Oh, it's okay, I see what it's doing. It's truncating it. So these are the amount of times that this user, that CSI 135B25 has logged in. And again, it's going to truncate it. So if we didn't want it to truncate it, and you take a look at the man page, there's an option in the man page that will display, or for last, there's an option with the last utility which will actually display the entire column, and that's the one we want. Display full user and domain name. So if I were to type in last -w CSI 135B25, then it would show me B25. So let's go in there and let's edit user login.bash, and we'll put last -w and the $ID. So now when I run the script and I type in CSI 135B25, the output is no longer truncated. We see the full login ID of the user, and that's what we want. So let's cat out that script one more time, and this is what that script would look like. Again, very short script, 3 lines. Prompt the user for their login ID, read in the login ID and create the variable, and then use that variable with the last command. Okay. Number 3 says create a shell script using the if-then-elif structure that prompts the user for a file name and then checks to see if the file is readable or writable or executable. And you notice I didn't say and, it's or, and in that order. So let's cat out, whoops, if-then-elif.bash. So I've already created the script. This is a little longer. And so this is exactly what that script would look like. And then it closes with an else and says, you know, if the file's not readable and the file's not writable, and there's a small error in here, executable. So let me pull this guy back up. And we want to make this an X. There we go. All right. So there's your script. Very similar to what we did in class. Again, prompt the user for the absolute path name to the file, or if you didn't prompt the user for the absolute path name, it would only search in the current working directory. So then it's going to check if it's readable, it's going to check if it's writable, it's going to check if it's executable, and if none of those tests are successful, then it's going to echo, I don't think your file exists. And so that would be the solution to number 3. So let's run this and see what happens. And the absolute path name, let's check on user logins.bash. The file exists and is readable, and that is correct. If you remember from when we did the ls on user logins.bash, it is definitely readable. Now, what if I did a chmod, and we'll make it 500 on user logins.bash, and let's rerun that script. Path name is user logins.bash. And it says the file exists and is readable. So let's take a look on user logins.bash. And as you can see, the file is still readable. So what if I did a chmod on, whoops. We're going to go ahead and do a chmod, and we'll make it 100 on user logins.bash. Now let's run that script. User logins.bash, And it says the file exists and is executable. So it failed testing to see if it was readable. It failed testing to see if it was writable. But it succeeded because, again, the only permission bit set is for execute. So let's change it to 000. And then let's rerun our script. And we're forcing it now. It should go all the way down to the end. All 3 tests should fail. And it says, I don't think your file exists. Okay, so that was the small script for number 3. The final script for the lab was to create a menu that allows the user to select select 5 of your favorite things. And then you just simply print up what those things are. So 5things.case.bash. And so here's what that script would look like. Again, I wanted to make sure that the script was prepared, that way you don't have to sit through the creation of it. And here's exactly what that script looks like. Have a series of choices, and we're going to go in right now. Let me make sure that it checks for let's change these D's. Whoops. And then over here to D. And then to E, and then to F, or to X. All right, so there we go. Let me do capital A or lowercase a. So again, this construct in the case statement is checking to make sure that if the user enters a capital A or a lowercase a, or a capital B or lowercase b, that it gets caught. All right, so let's run this script ./5things.bash. So, or yes, case.5things.bash. So if I wanted to see my favorite dog, the German Shepherd, run the script again. My favorite color, yellow. Run the script. My favorite food, lobster. My favorite car. Oops. So when we do D, you'll notice that for car it comes up and says lobster. So let's go back in and take a look under, it's sure enough. So we want to change that, right? And we want that to say F-E-R-R-A-R-I, Ferrari. And then E is favorite movie. The good, the bad, the ugly. Great Clint Eastwood movie. All right, so now let's run that again. So favorite car, D, is Ferrari. Favorite movie, E, the good, the bad, the ugly. And what if I enter a choice that's not there? If I enter it in Y, it says that's not a valid choice, and that's what the asterisk at the end of the script does. So if I run the script now, and then I decide, you know what, I don't want to run this script right now, I'll do X. It simply exits me out. So again, this is what 5things.bash looks like. You've got your magic number followed by the absolute path name to the shell you want to execute the script. I have a blank line that gets printed up, and then I'm going to cat out this information with the endit construct so that my menu gets printed first. I prompt the user for their choice. Case $choice, so I'm referring back to the variable that I created when I read in the user's input, and then I simply check to see which input they provide. The asterisk is what gets sent to the screen, to the standard out, when the choice is not one of the choices that they can make, and finally close it with ESAC. All right, that was lab number 8 from last week, the Shell Script Supplement, and I hope you guys have found this helpful and educational, and that is it. I will see you all on Wednesday night. Have a great day.